everyone, welcome back to our channel. So in today's video, we'll be creating the most iconic Pacman game using Python Pygame library. So I'll be walking through the code line by line and let's get started. Start by importing our libraries. Import Pygame, import sys, import random, and finally import math. So first module is the Pygame library, which is a popular Pygame library for writing the video games. And next we have the sys, which is the system module, which provides access to some of the variables used or maintained by Python interpreter. And this allows you to interact with the interpreter itself. Next we have random. This random module is used to generate random numbers or selections, which can be useful for various game mechanics like randomizing the positions, behaviors, events in the game. Next, finally, we have math. The math module is going to provide some of the mathematical functions like trigonometry, logarithm, or square roots, which will be useful in the game development for calculating the distances, angles, and performing any other mathematical operations. Next, I'm going to initialize my Pygame using init. So this is basically we are going to initialize all the Pygame modules that you will be using in your game. So it's necessary to call this before any other Pygame functions such as displays, graphics, or handling user inputs. This is like starting the game, like kickstarting it. Next, let's define all the colors. So I have a set of colors defined for my game. So I'm going to use these colors, and these are nothing but the RGBK value, and I'm providing it inside a tuple. Next, I'm going to define the screen dimensions. So I'm going to define the width and height of the screen. Next, so the width and height is going to be set to 600 and 650 pixels. So the width is of the screen is going to be 600 and the height is going to be 650 pixels. Next, the cell size is set to 40. So each cell of each grid is going to be 40 cross 40 pixels. Next, these are the screen dimensions, and next we are going to define some of the constants like the grid constants for defining the grids. So I'm setting it to 15 and the width and height to be 15. So basically the number of cells horizontally in the grid is set to 15 and the number of cells vertically is also set to 15. Next, I'm going to have some game states. So for that, these game states are very important. So I'm going to define the game states, two game states constant. One is playing, another one is game over. So the playing constant represents the state when the game is running and the player is controlling the Pacman. And the game over constant is going to represent the state when the player has lost or completed the game, basically game over. And these two are used to easily manage the flow of the game based on the player's progress. Next, we have to define a global game state. So I'll call it as global game state, and that is set as game state equal to playing. So basically this variable is going to store the current state of the game. So initially the game starts in the playing state, meaning the game will run and respond to the user inputs. You can change this to game over as when there are certain conditions met, like the Pacman gets caught by a ghost or the level is over. Next, I have to create the screen. So I do that by using a variable called screen. So let me create that. So here I set screen is equal to pygame.display.set mode, and I pass in the screen width and height. So basically this line is basically to create the game window where everything will be drawn. All the contents are within this window, and and it uses this particular function to create the screen with a specified width and height that we mentioned earlier as a constant. Next, we are going to set the title of our game. So using this method, which is an inbuilt method also, which is pygame.display.set caption. So the caption is set to Pacman. So this is going to be appearing on the top of our window, game window. Next, I'm going to create something called font for the score. So basically this is the font for the score. So I have a variable called font, and I use this method pygame.font and set it and pass in none and 36, meaning a font object that will be used to display all our scores on the screen. None here meaning it uses the default font which is provided by the Pygame. You can use whichever font that you like, but here I'm just going with none. And then 36 is going to specify the font size, and this will likely be used for rendering our text like the player's score or any other messages that we want to display in the screen. Next, I'm going to define the game grid. So this is the game grid. So I have it defined in a list. So basically this is a 2D list. You would have heard about 2D list in Python. So the innermost list represents a row in the game world, and each element of those inner rows represents a cells in that row. So basically the values in the grid defines the type of title in each position. So 1 will represent a wall or a boundary so that the Pacman cannot cross or pass through, and 0 represents open space where the Pacman can move, and typically where the pellets or other items will be placed. So the first row that I have defined is all ones, meaning it's entirely the wall. So first and the last is set to 1, all ones. So basically it sets the boundary of the game. And the second row is set to 1 0 0 0. So this has both walls at both ends and open spaces in the middle where the Pacman can move. And rows like this has a mix of all ones and zeros where we want to mix has walls as well as paths for the game maze. This is how it works. Next, I'm going to create the game hero, which is the Pacman. So let's go and create the Pacman object. So basically I give this Pacman inside a dictionary. So this dictionary stores the current state and properties of the Pacman, such as the position and direction, and it helps to keep the Pacman's data organized in one place. So that's why I want to put all of them into one dictionary. So here x is set to 1. So basically this represents the Pacman's current position along the x direction, x meaning horizontal on the grid. So and the y is representing the vertical meaning the current y position, which is a vertical position in the grid. And then we have the direction set to 3. So this value represents the direction Pacman is currently facing or moving. So here I have this comment. So if it is 0, then he is going to move in the right direction. If it is 1, it is going to be moving in the downward direction. 2 meaning left and 3 meaning up. And then by default I define the mouth open variable to false. So this boolean value tracks whether the Pacman's mouth is open or closed, and it's likely used for the animation purposes to alternate Pacman's appearance as he moves. And as the Pacman moves the maze, these values can be toggled between true or false, that is mouth closed or open, to simulate his iconic motion. So the next thing that we are going to do is we are going to define the ghost. So for the ghost, I'm using this one. So this is a list that contains the dictionary. So basically I have a list containing dictionaries where each dictionary represents a single ghost in the game. So each ghost is defined by its position, X and Y position, and its color. So this list will make it easier to manage multiple ghosts within the game and update their positions and behavior. So the first is I have set X to 1 and Y to 13 and color red. It represents the first ghost, and the ghost starting position is 1, 13 on the grid. So it will be in the second column and the 14th row. So the ghost color is set to red. So this might represent Blinky, the famous red ghost from Pacman. Next we have the pink one. Similarly, I'm setting the position to 13 and 1 in the 14th column and second row. It's just the vice versa. And this is the pinky ghost. And then the third one is the cyan, setting it to 13 and 13. So this is going to represent the inky one, and orange is going to represent the orange ghost. Now so these are the four colors that I'll be using for my Pacman game. So the next one, I'm going to initialize the player's score. So I'm going to set the score variable to 0. Here this is going to at the start of the game, so we don't want anything to be updated, so I'm setting it to 0. As the Pacman eats the pellets, we can start incrementing the score. This variable will be updated during the game and displayed on the screen for the player to track the progress. Next we are going to create the game loop. So for that, let's create the game loop. So clock is set to pygame.time.clock method, and I'm going to create a variable called running and set to a boolean true. So here this is the main loop that is going to start our game and is the core of our game, basically ensuring that the game updates and renders continuously until the player exists. So I'm using this variable clock, and the function that I'm going to use is pygame.time.clock. This creates a clock object that will control the frame rate of the game. So the clock ensures that the game runs at a consistent speed and limiting the number of frames per second. And then we have running set to true. So this determines whether the game should continue running, and we can use this as a flag when running the game. Next we are going to update the movement delays. So that is done using movement delay variables. So I have a set of movement delays such as Pacman move delay, ghost delay, the mouth animation, last Pacman move time, last ghost move time, and last mouth animation move time. So first is the Pacman move delay set to 150 milliseconds. So this is going to all these are set in milliseconds as I have shown here. So this defines how often the Pacman can move. So the value is set in the milliseconds, basically meaning that the Pacman can move approximately every 150 milliseconds. Next, the ghost move delay is set to 300, how frequently the ghost can move. So it's greater than the Pacman, so it's set to 300 milliseconds. Next, the mouth animation delay. So this is how this controls how the Pacman's mouth animation should be updated, and the delay is set to 600 milliseconds. Next, we have these three are nothing but the timing variables. So let me call it as timing variables. So these timing variables will track the last Pacman and ghost moved or the mouth and the mouth animation changed. So the last Pacman move time is set to 0. This tracks the last Pacman moved. Initially it will be set to 0 and it will be updated with the current time. And then similarly we have for the ghost. And finally this variable called last mouth anime will record the last Pacman's mouth animation updated. And the game loop will check this against the mouth anime delay to decide when to switch between Pacman's mouth being closed or open. Next, let's define move Pacman method. So in here I am going to define a global variable called score. Then I have define dx and dy, and I'm going to set that to a direction inside a list 1, 0, 0, 1, minus 1, 0, and 0, minus 1. And next is the Pacman direction, and I have new x, new y. I'll let you know what I'm doing in a while. Let me finish this game logic. Plus dx, Pacman of y plus dy, and if the grid new x and new underscore y is not equal to 1, then I update the Pacman position, x and y position. As new x underscore new y, and if grid of new y new x equal to 0, then grid of new y and new x, it will be set to 2 as mark as eaten, and the score gets updated by 10. Okay, so this is a function which is going to handle the movement logic for the Pacman, determining how a Pacman moves based on his direction, updating his position on the grid. So the first one is I'm going to define a global variable score. Next, this score variable will be updated whenever there is a enemy or the ghost eaten and the score gets updated. Next, we have this line which is dx, dy. So this line is uses a list of tuples. So basically this is a list and it contains tuples to define the movement in 4 directions, that is 1, 0, 0, 1, minus 1, 0 and 0, minus 1. And then we have the direction, these are the 4 possible directions, which is moving upward, downward, sideways, right and left. Next, this Pacman's current directions will be determined by this direction variable that we previously created. So next we have new x and new y. So that is going to calculate the new position of the Pacman that he would move based on his current position x and y. So Then we have a grid called new x and new y if it is not equal to 1, meaning this checks whether the new position is not a wall. So in the grid, 1 represents a wall, as I mentioned, as 0 represents space to move. So if the value at the grid is 1, then the Pacman can't move there. So he's no, basically if it is not a wall, maybe it's a 0, then the Pacman can move there, and rest of the code inside the block is executed. Next we have this Pacman x and y here new. So this is nothing but if the Pacman's new position is valid, then this updates this is updated as a current position, the current coordinates for the Pacman, and this effectively moves the Pacman on the grid. Next line, it checks if the grid y comma x is equal to 0. So if it is 0, then the Pacman can move in the space and with a pellet, and then the game needs to handle eating the pellet. So this is done using the grid position. So here we are setting the value to 2, and this indicates that the pellet has been consumed, and it will prevent the score from increasing again if the Pacman returns to the same position. And we increase the player's score by 10 points whenever the Pacman eats a pellet. Now let's define the ghost movement by this method. So I have a method called ghost movement, and I'm passing in the ghost as a parameter into this method. So here this function is basically to handle all the ghost movements, and it determines which direction the ghost will move and updates its position accordingly. Likewise we saw in the Pacman movement. So the first one, similarly we have the directions. So this direction is similar to the Pacman movements. It defines the list of tuples for the 4 different directions. And then we have random dot shuffle and the pass in the directions. So basically this randomly shuffles the list of directions so that the ghost doesn't always prioritize on one specific direction. And by shuffling, this adds elements of randomness, causing the ghost to choose a different direction each time it tries to move. Next, for dx and dy in directions, this this loop iterates through the shuffled direction and attempts to move the ghost in each direction. So new x and new y is a new coordinate for the ghost, and it gets updated. And if we see that if 0 is greater than new x of the greater than width, and 0 is greater than equal to new y greater than width, meaning this condition checks whether the new position is within the bounds of the grid. So the ghosts can't really move outside the defined grid. So basically this is going to check the valid columns and of the grid, and ensures that we are not equal to 1. And this condition will ensure that the ghost doesn't move into the wall, and it's only allowed to move into the spaces. Once it's valid, then it updates the ghost's new coordinates using new x and new y, and then it breaks from the loop after the ghost's moves are successfully updated, and it breaks out of the for loop. Now let's go and draw all our Pacman characters. So for the draw function, I have this condition. So I have a function where I'm going to draw my Pacman. So that is done using this method called draw Pacman. So this function is basically responsible for drawing the Pacman on the screen with his position, color and animation, that is mouth being closed or open. So it also ensures the Pacman's direction is accounted for when the rendering the mouth opening. Next we have set this x and y. So basically the x is defined as Pacman's x position times cell size plus cell size by 2. So these two lines will actually calculate the Pacman's position on the screen, and this converts the Pacman's grid position into pixel coordinates on the screen by multiplying it with the cell size. And cell size by 2 is nothing but this adjusts uh, and adjustments the centers the Pacman within the cell by adding half of the cell size. So, and we give an extra 50 on the y coordinates is likely to be used to account for an offset. Perhaps the UI elements or the specific layout of the game window. Next, we define the mouth opening angle as 45 if Pacman mouth open is true, else we set it to 0. So we open the mouth to 45 degrees if this variable called mouth open is set to true, otherwise we set it to 0. Then we are going to draw the Pacman using this method called draw, and it's going to fill in the screen, and then I given the color, then x and y coordinates and the cell size so that it fits in the grid. Next, we are going to calculate the angle for the mouth based on the direction that is going to move. So first one is this: if Pacman direction is set to 0, then it's going to move in the right direction, and the starting angle will be 360 minus the mouth opening angle divided by 2, and the end angle is going to be just the mouth opening divided by 2. So basically this is when the mouth opens towards the right with the start and the end angles calculated relative to the 360 degrees. Similarly, we have different loops for different directions: downward, left and upwards. Next, we are going to draw the mouth using a pie shape arc. That's done using this method. Next, we are going to draw a line from the center to create the slice effect. So those slice effects are basically an arc of line or two that are drawn from the center of Pacman to the edges of the arc to create the pie slice effect. So that is done using the math library that we just imported. So math.cos and math.sin are used to determine the position for the line's end based on the start and the end angles. Next, we draw the line based on the calculated x and y positions. Next, let's draw the ghost. So we are having this method, this function called define ghost. So this method is responsible for drawing a ghost on the screen, and it's currently its current position with this and assigned color. So each ghost will be rendered as a circle. So here we have the x and y variables set to ghost x, cell size, and this is similar to the one which we just did for the Pacman. So here this calculates the ghost's horizontal position on the screen, and this cell size is going to convert the ghost's grid position to the pixel by by multiplying it by the size of the grid and dividing it by 2. So this is going to center the grid cells, and then likely in the white direction we add some offset, and finally we draw the ghost using this draw function and pass in the screen a ghost color, x and y coordinates and the cell size. Next, we are going to define our reset game function, which will be which is going to basically reset the game's state to initial configuration. So to do that, I define this method called reset game. So this function will basically called when the game starts, and after the player loses all the lives or the level is restarted. It's helpful to restart the Pacman's position, the ghost's position, score and the grid. So that is done using this method. So the global variables Pacman, Ghost, Score, Grid and Game State are the variables defined as global, meaning the function will modify these variables that are defined outside the function. Next we have the Pacman's starting position, the direction and all the attributes of the Pacman as well as for the Ghost. Then we also reset the score to 0 and grid is also resetted and the game state is set to plain. So these are the initial conditions that we want to set when we reset the game. Next, let's move on and do our drawing the game over function. So the game over is going to be done in this function. So this function will be responsible for displaying the game over screen when the player loses. So it displays the game over message for the player, and it also displays the score as well as it instructs how to restart the game. So first we fill the screen as black in color. So we define that, and then the game over font. So the font I'm using here is none, so it will be the default font and the font size 64. So game over is going to be printed as the largest font. Then the score, and then we have the restart font. Next, the game over text is going to be defined using render. So this render is an inbuilt method in Pygame. And here we also have for the score. So we just call in the score variable here, and for restart we just say an instruction, say press space to restart. So when that's true, then it restarts the game. And then finally we have something called blit. So this is going to basically draw our game over text and score text and restart text. Next we are going to go to the main game loop. So let's start with the main game loop. For that I'm going to set running to true, and then the clock is set to start. So next we have this condition called while running. So basically this game loop will continue to run while the running variable is set to true, and this loop is also going to calculate the score and update the state and whatever needed for the game. This the core logic that we have for our game. So while running, we are going to specify the current time to pygame.time.getTicks. So mainly the time handling. So this pygame.time.getTicks returns the number of milliseconds since the game started. So this is used to manage the movement delays for the Pacman and the Ghost as well as the animation. Next, this is also essential for handling our events. Next we have for event in pygame.event.get. The first event that I want to check will be quit. So when the user is going to quit the game, is checked in this event. So I go and set my running variable to false, meaning the game is over or ended by the player. Next we have the if else, where I check the event type, whether it's key down. So if the user is going to press any of the key, Then I enter into this if loop and start checking the game state, whether the player is playing the game. If that is true, then I enter event dot key equal to pygame dot k underscore up, whether he's pressing the up key. So then I have to move the Pacman's direction to 3, meaning it moves up. Next, else if event dot key is equal to pygame dot k underscore down, then Pacman's direction has to be set to 1. Sorry, this should be just 3, not equal to. Next, else if event dot key is equal to pygame dot k. So if it's going to press left, then I'm going to update Pacman's direction to 2. Else if finally event dot key equal to pygame dot k right, then Pacman direction equal to 0. Finally, if the player is not playing the game, then we check for game state, whether it's game over. Then in that case, if event dot key pressed is going to be the space key, in that I just call the reset game function. Now let's start updating the game state for each items. So the first one I want to do is if the game state is going to be playing. So I have this. So I say if game state is playing, then move the Pacman only if enough time has passed. So this is calculated like if current time is minus the last Pacman move time greater than move delay, then I call the move Pacman method and update the last Pacman move time to current time. Next, similarly for ghosts, I calculate for the ghost, if the current time minus the last ghost move time is greater than ghost move delay, then we have to check which ghost for ghosts in ghost and move that particular ghost here and set the current time as the ghost last move time. Next, we are going to animate the Pacman's mouth using this. So Pacman's mouth movement is updated when the current time minus the last mouth and animation time greater than this. Then we check if the mouth open is true, then we update it. Then finally I'm going to draw the maze. No, and before that we have to clear the screen. To do that, I just say screen dot fill black. Finally, next I'm going to draw the maze. So using this, so for this I want to draw a maze. So for that First I have for y in range of the grid height and for x in range of width. If both grid y and x direction is 1, then I draw a rectangle. Otherwise, if it is else if, then I draw a circle, which is the pellets. Now let's call the main function called draw Pacman method. Then for ghost, in ghosts, I draw ghost and pass which ghost, because we have 4 colors. Then finally, so this is for drawing the Pacman, and this is to draw the ghost. And finally we have displaying the scores. So I define the score text is set to font dot render and pass the score set to score and check if it is true, and display the text in white font. Then screen dot split, display the score text in this format. Finally, we are going, one last thing is we want to check the collision with the ghost. So to do that, we use this way. So we are checking for the collision for ghost in ghost. If both the x direction and y direction are same, then we have collided. So the game state has to be set to game over. Finally, we have to end this. So this one is starting. We have started this if, and we have denoted all the functions inside the playing state. If we are playing when the game state is set, and else if, we just check for the game state to be game over. So game over if, then we just draw for game over, just call this function. Then finally we will update the display by pygame dot display dot flip, and then we cap the frame rate as 60 frames per second for smoother transition. And then finally, when the user presses quit, we quit the game, and then we clear all the system resources by using this method, calling this method. So that's all for our game. Let's try to run it. Go to new terminal and let's run this. Okay, I have an error. So it says line 222. Okay, let's go to this line. Okay, I think this is a if condition. So I'm going to check equal to game over. Okay, another error, line 210. Okay, so this is not a function or something, it's just a callable object. Now let's rerun again. Okay, yeah. Now let's try moving. Okay, I think I have some issue with the logic. Let's go and check what is happening. So move ghost is the function that I'm interested. Not move ghost, sorry, new move Pacman. Okay. So in here I have a global variable dx and dy, new x, new y, correct? Okay. So if grid y comma x, then this is equal to 1, then we mark it. Now let's try rerunning it. Okay, so this is our window. Now I'm going to try to move the Pacman. So I'm clicking the up direction, downwards, left, downwards, right. Okay, so yeah. So whenever I get hit with a ghost, the game is over. So I have the game over displayed here, the score, and press space to restart. So that's it. We have created our Pacman game. So I'll give the code in the description box below, so you can try it out in your free time and see how it goes. So if you like this video, please give a thumbs up and subscribe our channel. So let's see you in the next video. Thank you.